Hi, in this video, we're gonna jump straight into Pandas and actually use it inside Jupyter Notebook. As you can see, instead of just talking about concepts, um, you will see how Pandas behaves line by line as we run the code and watch the results. Pandas has so many methods, and each method comes with a lot of options and parameters. So it is completely normal to feel a little overwhelmed soon as you start working with pandas. But the good news is we're just going over the basics here. And I'll promise you, as you start working with it and experimenting with it, things gonna make more sense and you're gonna feel more comfortable and things gonna get easier to even memorize everything. Like I said, we're just going to go over very basic, and as you follow along this notebook, you will see exercises. These exercises are for you. See if you can do them. Pause the video, and once you finished it, keep going and just go to the next part. Hopefully by the end of this walkthrough, you should feel comfortable reading pandas code, understanding what the code does, and being able to make a small changes on your own data. So as you can see, you can double click on any of these cells. For example, this is a markdown cell. You can run everything cell by cell, and for running each cell, you can use Shift Enter, or you can click on this, or you can come here and click on all the cells together, or you can click on this. You don't really need to do that. You can just click on the cell and use Shift Enter. There we go. That. All right, so if you already installed Anaconda, that means you have Pandas already. But hopefully you install Anaconda distribution version 1, because this is the one that actually install all the necessary libraries. If you haven't, just go back and just install Anaconda distribution, reset your machine, and then run the Jupyter Notebook, open this notebook, and you should be good to go. I'm importing Pandas, and I'm going to use PD instead of that. I'm also importing NumPy. I didn't use NumPy anywhere here, but just I kind of got used to it. This is also very good library. It allows us to work with a list of data in a very fast and efficient way. I also imported Matplotlib library, which we're going to use at the end of this notebook to actually plot our data and look at our data. So if you have it installed, I'm going to run this. You will see a version like this. You might have older version or newest version. Doesn't really matter. Even if you have an older version, that's fine, because we're not going to do anything crazy here. Like I said, we're only going over the basics, so you should be fine. All right, so the first method is a series method. Basically, it allows you to create a one-dimensional like labeled array. The good thing about labeling your data is that you can also have access to each element through its dedicated label. Look at that. Like, for example, let me run this. Like, I want to get the element at that has the label B. You can just do that, or you can still call this iloc method and just provide the index of the element and basically get the same result. As you can see, when I run it, both of them are returning number 20, which is this guy here. There is a small exercise here for you. See if you can do it on your own. All right, move on to the next. Probably data frame is one of the biggest thing that pandas provide. Basically, is a two-dimensional table, and you can label all the columns and rows and everything, which is great. By having this data frame, you can actually hold on to your data, and by mentioning those labels, you can actually get access to your data and clean your data and visit your data in a very fast and efficient way. So as you can see here, I just created like a two-dimensional array. So this is what's going to go on the first, like the name of the elements. Like, for example, this is the column name, and these are the values that I want to save inside it. This is the column age, and these are the numbers that I want to save inside it. This is a column score, and these are its value. Once I create my data, I just provide it to this method data frame, and from that point forward, boom, I have a data frame type. And as you can see, when I run it, it gives me this nice table. It has columns, and you can have access to each column by providing the column label and also the index of each row. It's very neat, it's very clean, and with that comes a lot of method now. Look at that we can use to actually study our data, fix things in our data, even plot our data, so many things. So let's just start with that. Let's just start with study our data. So when we want to study our data, we usually start looking at like the head of our data. We just look at couple first rows, see what we have here, how many rows, how many columns, what type of data we have, things in that nature. So if you run the head method on your data frame, it gives you like the first 5, 6 row of the table. We only have 4 rows here, so it gives us that. And if you run the info method, it gives you pretty good detailed information about your data frame. You have like 4 entries, 3 columns. It also gives you the type of each one. So it basically gives you a good detail of everything. There are more methods, but like I said, we're just going over the very basics. We also have this scribe method that provides pretty good information. Like it tells you how many elements you have here, and basically it gives you like a detailed information about the columns with numbers. So for example, we have 4 ages, 4 scores, the average is this, the standard deviation is this, the minimum value is this here and here, the maximum values are here. This 25%, 50%, 75%. For example, this 25% means that 25% of all the values less than or equal to this number. So it basically gives you a rough idea of like how numbers are in this column. Depends on the situation, could be a good information in case we want to know how scattered our data is. And then you want to get access to rows or columns or a specific element. You can call the lock method, provide the index. It returns the whole column at the index of 0. Here you want to get 2 rows starting from row 0 and row 1. You can do it like that. You want to get the element at the index of 0 and 1. You got to use the ilock method. You can also use the label. So for example, here you want to say give me the element at the index of at row 0 and the column labeled age. For example, you want to get the whole second row, you can do that. So if I just run it, as you can see, it provides all the informations. Here's another exercise for you, see if you can do it. That was just very basics, just looking at our data, creating a data frame and everything. Data is usually very big, so we usually read the data from a file. We don't have a CSV file here, so I just created this CSV data kind of similar to CSV file here. And basically I just read from this data. But in reality, if you have a file, as long as you put the file in the same folder as this notebook, you should be able to call the read CSV method and just give it your file name here, and boom, that's it. It's going to take care of everything for you. We don't have a file here, so I just created like a data with the similar text that you can find inside the CSV. Then I provided that as a file. So I have this now. I was able to read it as a CSV file. And as you know, CSV file, all the elements are separated by comma separated value. That's what the CSV means. So this is how my data are going to look like. And as you can see, when you use Panda to read from a CSV file, by default, it gives you a data frame, which is nice. Right off the bat, you can actually run the data frames method to study your data. So first thing first, as we already saw, You can look at the head of your data, see what type of values you have. You can look at the labels that you have for your column here. So you have ID, name, age, and so on. You want to know if you have any not a number type element in your data, like this. This is called not a number. Basically, this is a wrong data here. So you can actually call this is NA method, and that gives you how many not a number element you have on each row, and then you can call the sum method to add them up, and eventually tells you how many it can find on each column. So if I just run this, so it tells me there's nothing on ID column, but we do have one in a score column, which is right this guy. So that's good. That's good when we want to look for errors. So we eventually need to fix all these errors. Count how many unique values we have here. So in this in the column score, we want to just count how many unique values we have, and basically we also want to drop those elements that are not a number. So that's the method. So it tells us like we have two 400s, 188, 192, one not a number, 190. It still appears in the results, but it's not counting basically. Sorry, okay, I made a mistake. It's not about counting. It basically, we are telling pandas, oh, I thought this is true. This is false. Basically, we are saying include, also include the not a number. If it was true, it wouldn't include not a number. But since it's false, I just assume it's true. I didn't pay attention. Sorry about that. So it's false. That means we do want to also count not a number values. And as you can see, it counted for us. We have one of that. So basically, this is one of the errors that we might find. And eventually, we need to fix those. We need to clean our data. So this is the next thing that we usually do. We clean our data. We clean our data in different ways, so many of them. These are just some very basic ones. First thing first, let's just not mess up the original data. So I just got a copy from our original data. So from now on, we're going to use this data frame. And you can call the drop NA method. It looks for this element NA, not a number value, and it's going to drop that row for you. So dropping the row, it's one way of cleaning the data. Another is that we're just going to get the average of other values in the same column, and we're going to use the average. Or maybe we can use the median or the mod of the same column, and we're going to use that to fill up and substitute that not a number value. So again, I just got a copy from my data because I don't want to mess up my data. And then all you can do, you say, okay, get the average or mean of all the elements from this column, but skip the not a number value. So it's just going to calculate the average of this column, and it's going to skip this one. And then we're going to use that to put it instead of this number here. So we're going to use fill not the number. We're going to provide that mean value that we calculated here, and that's it. Now, if you look at the data, there we go. As you can see, that was the average we got here. And now that average is sitting instead of not a number value that we had here. So there's another exercise here for you to do. Another thing that we need to look at and clean up is when we have wrong format data. For example, this usually happens when we have like hours and date, stuff like that. Look at that. So in joint column, so we have this here, which is obviously a wrong data. So we can mark it as not a time, which is kind of like a very specific type of data that later on we can actually remove it. So let's just go over this column and basically find any element that has errors in it. So we're going to call this method. We're going to go over all the elements in this column, and we want to look for wrong values here. Once we get that, and what this one does is just going to find the wrong values, and it's just going to change them to this value. And as you can see, when we print that, there we go. So now this got changed to this. Why do we need to do that? Because not a time type is something now we can just call a method and take care of it. So for example, if now we look for not a value or not a time, there we go. It can find it. It can actually easily say, oh, you have one element in this column that is not a value, the right value. And then we can call the drop NA, provide the column. It's going to go through it. And if it finds the NA value, boom, it's going to clean it up for us. There we go. It's gone. So that's why we're transforming it first to not a time type, so we can actually use the methods that we already have. Another type of wrong data could be like the outliners. The outliners are like very small values or like very big values that are not supposed to be there. For example, like the score is not supposed to go above 100, but we have like 200 or 400 here. So these are like outliners, like impossible values. Like the age could be like 200 or negative value. So these are like a impossible value or outliners. These type of data we also need to take care of. So again, don't mess up the original data, get a copy from it. And then we go over our score data and basically we clip it. So we basically convert all the values above 100 to 100. So now when we run this, all those values above 100 now are changed to 100. And basically we added an extra column here to our data, as you can see. So this adds an extra column that is clipped and fixed to our data frame. Or we can basically, from our data, we can actually filter all the elements from this column that are less than 100, and we can just grab that part. And as you can see, I'm doing it. I'm getting a copy and I'm saving it inside this variable. So now I only have some rows that their score is less than equal 100. So that's another thing you can do. There is another exercise here for you. See if you can do it. The next thing that we usually do as part of cleaning the data, we just remove duplicates. We don't have any duplicates, as you can see. Like for example, if you run the duplicate and then sum, if you do have a duplicate row, it's going to give it to you here, like how many you have. We don't have any here, but if you do, all you need to do, you just run this drop duplicate method, and if you do have any, it's just going to get rid of it for you. You don't need to really look at all the rows one by one. It takes care of everything for you. The coloration is also a very good thing that we usually do when we want to understand the connection and correlation between different columns. In this case, our data is not big, so for example, we only have like 2 columns with numbers that we can actually investigate the correlation on. But the correlation is usually a number between -1 to +1. If it's positive, that means those columns have higher correlation. If it's 0, that means no correlation. If it's negative, that means a kind of reverse correlation. So for example, here, age, as you can see, they're like in full correlation. But the age and the score, like kind of no correlation, is slightly reversed, just a slightly reverse correlation. But we don't have a big data. This data is just unstable. That means whatever result we get out of this, you cannot trust it. But if you really have a big data, this correlation method, this core method, gives you a very good idea. Because one of the things that you need to detect is correlation between like different columns. For example, you want to know if whether or not those people who are older have like higher score or lower score. So if you have a lot of data, you can actually get that result out of your data if we look at all the numbers and we do calculation on that. So that could tell you, by just knowing, maybe by just knowing the age of person, you can kind of guess and predict whether or not the score going to be high. So that could be one thing you can do. So we always want to look at the correlation between different columns in case we want to find any direct relationship or even reverse relationship. So we're going to use that later on to analyze the data. So another thing that we want to do is just by looking at tables and numbers, you cannot really find anything meaningful. You want to draw things and visualize things. Believe me, it helps a lot with understanding the data better and finding the relationships and meaning in our data. On your data frame, you can just call your plot method and just provide, okay, what values you're providing for the X axle, and we're going to use a column age, and we're going to use column score for the Y axle, and we're going to use a scatter plotting. So this is good when we want to kind of compare two columns to each other and look at the correlations. We don't like, as you can see, the data is very small. You cannot find anything meaningful. But that's one of the things we can do. With the scatter plotting, you can provide two columns and you can see if there are relationship between them. If there's a relationship, they're all going to sit like in one spot very close to each other, which is a sign there's a meaningful relationship between those. Or you can call, you can plot only, for example, your score column, and we're going to use a histogram to see how many accordance of each value we have. So here we have two accordance of value between 100 and 150. We have one accordance of value 250 and two accordance of value 400. So again, that could give us some meaningful information. Like I said, we're just using like basics. I didn't use the matplotlib here. I'm using the plot method from our data frame and pandas. The matplotlib, if we just use that directly, we have more options. We will do that in the future. But for now, we're just studying and playing with the pandas. Yeah, these are just very basics ones. There's another project, like mini project for you. Go over it, run each cell, play with it, change things, try to work on the exercises. Believe me, after just running everything, you're gonna feel much better about like all the details and everything.